Alright, in this video I'm going to go through an introduction to matrices. I'm going to look at this system of equations here, and then I'm going to apply that to a larger matrix for the next example. I'm going to show you how to solve this system two ways using a calculator. The first way is we're going to do an inverse, and the next way we're going to do a reduction. So the first step is we have to look at this system of equations and make sure all the variables are aligned. And in this case, they are, makes it much easier. I'm going to set my matrix A, which is going to be the left side, to 2, 1, 5, negative 3. I'm going to set my matrix B as the right side. That's going to be 5, 2. How a matrix equation works is we have to put it in this form, AX equals B. We're used to this in algebra, but we have to use matrices now. So we know what A is and we know what the B is. X is the values that are unknown. In this case, we have x1 and x2. So I can put it in that form. So I get 2, 1, 5, negative 3 multiplied by x1, x2 is equal to 5, 2. You know it's right. If you look at the top variable, it's going to multiply to the first column of your matrix, while the second variable is going to multiply to the second column of your matrix. So what we're going to do is I'm going to multiply both sides by the inverse of A. So it's going to be 2, 1, 5, negative 3 to the negative first. I'm going to multiply that to this side over here. Multiplying a matrix by its inverse is actually going to be equal to 1, so it just cancels out the left side. So on the left side, all we're going to have left is x1, x2. And that's going to be equal to 5, 2 times the inverse. 2, 1, 5, negative 3 multiplied by the inverse. It does matter how you put this in the calculator. It will change your answer. In this case, I'm going to put the inverse first, as that's the proper way to do it. So in the calculator, you're going to go to Shift Matrix, and you're going to go over to Edit. We're going to be editing a 2 by 2 matrix, and your matrix has to be 2, 1, 5, negative 3, following your matrix A. We're going to do the same thing for the B matrix. You're going to go to Edit, and you're looking for a 2 by 1 matrix. Now you can edit what the matrix size is there. In this case, it's 2 by 1, 2 columns, and 1 row, and that's just 5, 2. If you exit everything, you can go back to the matrices and click the matrix that you want inverse, and that's the 2 by 2 matrix. You're going to raise it to the negative first power. That's what an inverse is. And we're going to multiply this times our matrix B, which is the 2 by 1 matrix. If we enter that, we get our x1 and x2 values right there. This method of doing matrices is tedious because you have to do two separate matrices. There is another way to do this to make it much quicker when you're doing a problem. I'm going to show you that now. It uses the same idea of having A and B. We're still going to put it in the form AX equals B. But instead of having two separate matrices, let's put it in one big matrix. What we're going to do is the calculator is going to actually reduce this to a form known as reduced for echelon form, and it's going to look something like this. It's going to strictly give you your x1 and x2 values just using one matrix. This way is much more intuitive of a sense of putting everything in one matrix instead of two matrices. So again, how do you put this in the calculator? Again, all you're going to do is you're going to shift matrix and you're going to go to edit. We're going to edit a 2x3 matrix this time because we have 2 rows and 3 columns. And again, our matrix is 2, 1, 5, 5, negative 3, 2. We're going to get a shift matrix now, math. But before you do that, make sure you exit everything. Go to math, and we're going to go down to RREF, known as reduced echelon form. We're going to enter, and we're going to put in our matrix that we want. In this case, we want the 2x3 matrix. If we enter this, again, we get the same exact answers as before. Just remember that you do the inverse multiplied by b. If you do it the other way, you will get a different answer because matrix multiplication is not commutative. Okay, now that we have this, let's look at a bigger matrix that we can solve, which is going to be down here. In this matrix, we have 6 unknowns, and we're going to have 7 columns. I'm actually going to go ahead and put this into one matrix. Again, if you want to put this into 2 matrices, you can. Just follow the steps I did for the smaller matrix, and it will be the same. I'm going to put this into a 6x7 matrix, where we have 6 rows for the unknowns and 7 columns because of this right side. I'm going to put it into AX equals B, but in the calculator, I'm going to put us into a 6x7 matrix by including this right side. Okay, let's go through the process. I'm going to start with this bottom equation. Again, remember this I1 multiplies to the first column of the matrix. So I'm going to put 1 as the I1 because that's here. And again, I2 is 1, I3 is 1, I4 is 1. And if you look at V1 and V2, they're not there, so those are 0. The right side is 0.2. There we go. I'm going to go back up top for the next equation. Now, it doesn't actually matter how you put the equations in. You're still going to get the same answer either way. You just have to follow the rules of how these variables multiply into the equation. Okay, for the next one, I1 is 0, I2 is 200, I3 is 0, I4 is 0, V1 is negative 1, and V2 is 0. The right side is also 0. If you look at the rest of the equations, you can see all the right sides are 0, so I'm just going to put zeros for the rest of them. Like that. Working on the next equation, which is the I3, we have I1 is 0, I2 is 0, I3 is 300, I4 is 0, and then V1 is negative 1, and then V2 is 0. And the right side 0. Looking at the next equation, we have that I4 is 250, so I1 through I3 is 0. That's going to be 250. V1 is negative 1, and then V2 is 1, and then the right side is 0. I can look at the next equation. Which is 0, 0, 0, 150. V2 is negative 1 and V1 is 0. And it looks like I have missed an equation, this top one. So I'll go ahead and put that in. So I1 is 600. And then I2 is 0, I3 is 0, I4 is 0, V1 is -1, and V2 is 0. Again, we have 6 rows and a total of 7 columns. And here we have 6, but if you add the right side, we have 7. Okay, in the calculator, I'm going to put this bottom equation, I'm going to put it on the second row, and you'll see that here in a second. So how do you put this into the calculator? You go to Shift, Matrix, Edit, and we're doing a 6x7 matrix. We're putting it all in one matrix. And you can see here the 600 is on the second row. Like I said, it doesn't matter how you put the equations in, as long as you follow the rules of matrices. So if you scroll over to the right, you can see we have a total of 7 rows, a total of 6 rows and 7 columns. So how do you solve this? I'm going to go and exit everything. And I'm going to go to Shift, Matrix, go to Math. I'm going to go ahead and do Reduce Row Echelon Form. And I'm going to pick the matrix we want. We want the 6x7 matrix. And I'm going to press Enter. And right away you can see our answers. It tells you your I1, your I2, your I3, your I4, and your V1 and your V2. In this case, the problem was actually looking for V1, and that's 16 volts. Then you can use that to find the equivalent resistance. That concludes the introduction to matrices. From here on out, whenever you see a problem, I recommend to use one matrix instead of doing an inverse. The inverse matrices are not really intuitive. This method is a lot more intuitive than doing the inverse, but it's whatever you want to do. If you have any questions, please comment on the video and I will be happy to answer them. Thank you.